Okay, here we are at test hint number 28. You keep seeing Mr. Sustin run in and out because he's manning the camera and getting that started. The hint says, what is a positive ion? Is it? Yeah. What's a positive ion called?
Positive ion.
Well, yeah. And what else? Dude, what's a cation?
I don't know, but it has a plus sign in the middle.
Oh, yeah, it does.
So that's what I'm going to call it.
Okay.
Cat ion.
Cat ion.
Cat ion.
I have a cat.
Yeah.
My cat is very large and annoying.
There's nothing I can do about that.
I know.
So, yeah, cat ion.
Basic definition. Positive ions are cat ions, and I bet the next test hint has something to do with the negative ones.
Yeah, so.
Negative ones are called anions. Anion. Anions. That prefix an is in all
It stands
sorts of
for
negative words.
a negative ion.
Oh, there you go. A negative ion. Awesome.
So, number 13, the characteristics of ions.
Ooh, this is one of those all the following except or which is not kind of questions.
Yeah.
Read the answer choices. How many, you guys come to test corrections over and over and over again and like, but isn't this the right answer? I'm like, no, this one says which of these is not. Take your time and read the answer choices.
Mm-hmm.
Alrighty, so characteristics of ions, well, what isn't a characteristic ion? So if we said anions are positive,
No, because did we just talk about that?
yeah,
Cations are negative.
no.
No, that's not true. What kind of elements form cations?
Those would be metals. Metals tend to give up their electrons.
Electron losers.
They lose electrons, and electrons are negative, so they become more positive when they've lost their electrons. They make cations.
So, thinking in opposite terms, that means the non-metals usually
Yes.
form negative ions because they're electron gainers.
Right, they gain those negative electrons, they fill up their outer shell. Okay, so if you know those characteristics, then just stop and read the question, please. You're going to be fine.
31, the number of electrons in a given ion. Now,
So,
please realize this question says in an ion, not in an atom. So you have to think, put your thinking caps on, in an ion. In an atom, the numbers of protons and electrons are the same.
Right, because it's neutral.
Yeah, they are not in an ion. So you have to pay attention to the question.
Okay, so here is an example, the sodium ion Na+1. It's +1 because it has lost one of its negative outermost / valence electrons, the only one valence electron it has.
It used to have 11 electrons. It still has 11 protons. When it is an atom, it's neutral. If it loses one electron, it becomes a +1 ion. You have to be able to do some math. You've been doing this kind of math for like 10 or 12 years, believe it or not.
At least.
Yeah, don't let the chemistry get in the way of math that you know how to do.
Right, addition and subtraction, you are good with it. So quiz yourself using your periodic table. If we ask you how many electrons does the rubidium ion have, you should be able to go to the periodic table, find the column, and see how many valence electrons rubidium has. You know it's going to lose those because it's a metal, and just subtract 1 from the atomic number. If you're on the other side of the periodic table and you're looking at something like sulfur, say, and you know that it's a non-metal, it's going to want to gain additional electrons, how many away from that octet, that noble gas configuration is it? How many electrons would it like to have to get to the stable P6 configuration, and just add that many electrons to the atomic number. Alrighty.
Adding and subtracting.
Number 32.
These next two are, they look like they're duplicates, but they're indeed related questions. They ask about trends in atomic radius. And if we go back here, the atomic radius changes as you go down in a group. As you go down in a group, the radius gets bigger and bigger and bigger.
Because there are more and more layers of electrons, more and more energy levels.
Adding layers to the onion, and it just keeps getting bigger and bigger and bigger.
Sometimes they get a little messed up with the word radius, even though they know it from math. So when we're talking about atomic radius, we're talking about atomic size.
Yeah.
And that's due to the numbers of electron energy levels.
And then as you go across the periodic table, across a period or a row, the radius gets smaller. So wait, should we put the...
Oh yeah, the arrow goes over.
The arrow should go this way.
Yeah.
Right. It gets bigger when you're going this way. It's smaller when you're going this way. It gets smaller and smaller and smaller as you move away, because remember, you're adding electrons to the same energy level, and you're also at the same time you're making the nucleus more and more positive. So
Right,
they're
because more protons are
pulling.
in the nucleus as you go across a row. So those protons are exerting their influence. They're pulling those electrons in closer. That effective nuclear charge decreases the atomic size.